Good evening, viewers, and welcome back to my channel. In today's tutorial, we are going to look at another aspect of transformation or rigid motion, which is called translation. In translation means sliding a ship without turning or flipping it. So, if you want to translate a point, assuming this is our point xy, now we are going to add the translation vector. So, this is the translation vector. The translation vector is AB. So we add the translation vector to the point, then what we get, which is x plus a and y plus b, becomes our image. Now let's see how this is done. Assuming that we have this xy, so we have x comma y in the column form. So we have x, y. Now we have our arrow. Yes, so this xy, then we have, we can repeat this y, xy, which is our point here. Now we add this point to our translation vector, and mostly our translation vector is represented by a b. So we have a b. Yes, so this point plus the translation vector is going to give us this image, and this is the image you are talking about. So if you are given a point to translate and you are given a translation vector, we are going to use this approach. So you realize that here we are going to have the final image. So we add x to a. So you're going to get x plus a. Then you're also going to get y plus b. Y plus b. So this is the same as this one. So it means that we have translated this point, and now this is the image. So now we have an example here. Translate the point 2, 3 by 4, 1. So we say this is the point, and this is our translation vector. This is our translation vector. So what we are going to do is that our point, we are going to add the translation vector to the point to get our image. So this is our point 2, 3. This is our point 2, 3 plus our translation vector, which is 4, 1, plus our translation vector, which is 4, comma, or 4, 1, which is in a column form. Now, this is what you are going to get. Now, when you add 2 to 4, we get 6. 6 here. Then when you add 3 to 1, we get 4. Yes, so this is the image. After translating this point, we are using this translation vector 4, 1. You see, this is 4 is the same as this is 4 here. So that is the result we expected to get. So the point plus the translation vector will give us the image. Yes. So now let's try this example. Now we know that this is the point and this is the translation vector. So we get this point. Let's go to the graph and see how to represent that. Let's go to the graph and see how to represent that. So we know our point. We know our point to be 2, 3. So let's plot that point. So 2, 3. We have 2, 3. So here is our 2 and here is our 3. So we have the point here, 2, 3. Now our translation vector is 4, 1. Our translation vector is 4, 1. So let's go get our translation vector. Our translation vector is 4, 1. So now we know that since it is 4, x is 4, so you can stand anywhere, whether this side or that side. Then you move 4 units to the right. So 4 units to the right. So 1, 2, 3, 4 units to the right. Then you move 1 unit up. 1 unit up because it's 4, 1. Then you have the image there. Then you have the image there. So we have 4, the translation vector 4, 1. So let's see. This is where our image is. So if you want to label or name this point, which is our image, it is going to be 6, 4. 6, 4. So we have translated this point using the translation vector 4, 1. And this is the image we have. So it is actually true what we got here. So that is how we translate a point using a given translation vector. Now let's take an example. Triangle ABC has the coordinates A, which is 1, 2, B, which is 4, 2, and C, which is 2, 5. Translate the triangle using the vector 3 minus 2. Find the new coordinates of A prime, B prime, and C prime. So firstly, we have to plot these points. So the first one, A, is 1, 2, 4, 2, and 2, 5. So let's go to our graph. We know that we will add this translation vector to this. We will add this translation vector to that. We also add this translation vector to this. And we get the images of the various ones. So when you come here, this is what we have. So the translation vector 3, then this is minus 2. Yes, that is minus 2 because here is minus 2. So these are translation. This is the A and this is the B. The A is 3 and the B is what? Negative 2. So what you have to do is that wherever you see X, when you consider this first point, which is 1, 2, X will be 1. Then Y will be 2. So when you put 1 here, 1 plus 3 will give you 4. Then 2 minus 2 will give us 0. So we have the image for this point after translating this point using the translation vector 3 minus 2. When it comes to the second point, 4, 2, now it is um, there for you. So x is what? 4. So this is our x4. Put it there. Then 4 plus 3 gets 7. Then this is our 2. So 2 minus 2, we get 0 here. Then go to the last point, which is 2. This 2, put it, substitute it for x. So 2 plus 3, we get this 5. Then 5 here, 5 minus 2, then we get this 3. So now let's see how it will look like when you plot this on the points. So these are the points we have. So let's go to our graph. So let's go to our graph. Let's go to our graph and plot the points. So our first point is what? 1, 2. Second one is 4, 2. So let's plot. So 1, 2, 4, 2, and 5, 2, or 2, 5. 1, 2, 4, 2, and 2, 5. So let's plot these points. So we have 1, 2, 4, 2, and 2, 5. So we have this. Then you join this one. So we have a triangle, a beautiful triangle form here. So the first point E is 1, 2. So the x is 1, the y is 2. Then the second point is what? 4, 2. So this is the 4, and this is the 2. And the last point is 2, 5. So this is the 2, and this is the 5. Let's see if we have it correctly. So yes, 1, 2, 4, 2, and 2, 5. Now we are going to do the translation. So what is our translation vector? You know the translation vector is 3 minus 2. 3 minus 2. This means that you move 3 units to the right and 2 units downwards because this 3 is the positive x and this 2 is negative 2, which is on the negative y-axis. So if you are going to the negative y-axis, you move down. But since it is 2, you move twice down. But since x is positive, we are moving thrice or 3 times to the right to the positive x-axis. Then since the y is negative 2, you move downwards twice. So that is exactly what you are going to do. So 3 minus 2. So let's go. So let's go and take our translation. So translate by vector. Then we select this one. And this is what you are going to do. Since it is 3, it is 3, negative 2. 3, negative 2. 3, negative 2. So you can stand anywhere. So here, then go 1, 2, 3 to the right. Then come down 1, 2. That is where it will be. So this is the image. After translating this by translation, using a translation vector, 3 minus 2, this is the image you are having. Now let's see the point we have as our image. Now the first one is what? 4, 0. So A prime is what? 40. B prime is 70. And C prime is what? 5, 3. 5, 3. Let's see the solution. So this is our solution. So the translated triangle A prime, B prime, C prime has the coordinates. A prime is 40, 40, and this is our 40, 40. Then B prime is 70, B prime is 70, and this is our 70. Then our last one, which is what? 5, 3. And 5, 3, which is what? 5, 3 here. So we have been able to translate this one using a translation vector. So if you also do it manually, I only do this to show you how the shape or the triangles will look like. So if you also do it manually using the formula, you should be able to get it like this. Then if you have to, or if you are presenting on your graph, it should look like this. So if you are able to do this, then thumbs up. Now this brings us to the end of this video. In the next video, I'll be doing enlargement or dilation. So stay tuned and make sure you subscribe. Thank you.